There are many aspects to understanding the world we live in which can be categorized as philosophical because their outcomes have already been determined or are not completely apparent or measurable in our physical realm. The topic of germ theory is not such a case, as its implications are tangible and persistent. Take, for example, the recent increases to the price of eggs. Since early 2025, over 200 million hens were slaughtered due to the suspicion of avian bird flu. As a result of this bird sacrifice, egg prices more than doubled in the first quarter of the year. You might be surprised to learn that the same methods of clinical observation and testing technology used to confirm avian flu cases have been used throughout the decades to diagnose other diseases. More specifically, methods that fall apart under close scrutiny have been used to justify a variety of government mandates and medical interventions. For more insight into the use of PCR as a diagnostic tool, let's hear from PCR inventor Carrie Mullis.
And with PCR, if you do it well, you can find almost anything in anybody. It starts making you believe in the sort of Buddhist notion that everything is contained in everything else, right? I mean, because if you can amplify one single molecule up to something that you can really measure, which PCR can do, then there's just very few molecules that you don't have at least one single one of them in your body, okay? It doesn't tell you that you're sick, and it doesn't tell you that the thing you ended up with really was going to hurt you or anything like that. It doesn't tell you that you're sick, and it doesn't tell you that the thing you ended up with really was going to hurt you or anything like that.
Because the general public has been conditioned to take the word of allopathic medicine and mainstream science at its word, the majority participate in the intervention schedules shown in this table. Notice how the number of doses increased from approximately a half dozen in the 1970s to around 60 by 2025. There's a very large elephant in the room that correlates with this increase in interventions, which is forbidden in mainstream discussion, and whose proponents are routinely demonized in the press when bringing attention to the undeniable trend. An increase in food allergy cases can also be observed when plotted on the same graph as recommended doses in autism cases. Asthma and autism appear to follow similar trends. I acknowledge that correlation does not equal causation, but we mustn't ignore the data when it appears to be telling us a story. The question we must now address is how exactly we got to this point. Why do we as a society believe that medical intervention is needed from the time someone is born all the way through high school and beyond? How do we know whether or not there are invisible bugs capable of wreaking havoc on a human body and potentially leading to death? Can we find clear justification for the lockdowns of 2020 and subsequent mandates? Let's begin by looking at the key milestones in germ theory history for answers. The birth of immunology is often credited to Louis Pasteur for his work creating an attenuated vaccine for chicken cholera in 1880. However, most people are unaware of the experiments that led to this intervention's creation and how the remedy itself was concocted. Initially, Pasteur unsuccessfully attempted to infect guinea pigs with what was presumed to be cultured organism. He then concluded that guinea pigs were immune to cholera and that the pus formed in the abscesses of the injection sites contained the disease microbe in its pure state. He then conjectured that these pustules could infect chickens and rabbits living in the same proximity by spilling onto their feed. He offered no experimental proof for this hypothesis and instead attempted to imitate cholera transmission by feeding healthy chickens the diseased muscles of chickens who had died from so-called chicken cholera. He also attempted to prove transmission of the cholera microbe by injecting the blood and cultured broth of infected chickens into the skin of healthy chickens. These methods of infection were not just highly questionable, but it was also noted in the 1882 paper Pasteur's Experiments by Roland Gregg that the coagulated fibrin molecules that occur at the ejection sites were indistinguishable from bacteria known at that time. Furthermore, injecting coagulated fibrin into healthy chickens results in coagulation and disease within those subjects. Despite the questionable nature of these experiments, Pasteur later announced his development of an attenuated cholera vaccine following a series of very fortunate events. According to his semi-autobiography, one of his assistants forgot a virulent culture on a lab bench during his summer vacation in 1879. Upon his return, he was surprised to discover that the injection of this culture did not lead to death in a new crop of test hen subjects. He concluded that the culture lost its virulence due to exposure to air over time. Pasteur provided no confirmatory proof of this new hypothesis nor details about the new concoction when declaring its availability in early 1880. Curiously, he had instructed his son-in-law René Valery Rideau to never release his lab notebooks to the public. It wasn't until Pasteur's grandson, Professor Louis Pasteur Valery Rideau, donated all 152 notebooks to the French National Library in 1964 that we learned there were no journal entries corroborating the story about the forgotten culture that inspired the cholera vaccine. Instead, there was only one entry on January 14, 1880, in which he wrote, "Hens germs, when should we take the microbe so it could vaccinate?" Many questioned the effectiveness of this new remedy, including Pasteur himself, who stated, "The effects of vaccination are very variable, and that they rarely act as a complete preventative." That notion was later seconded by a 1959 paper entitled Studies on Control of Fowl Cholera, which stated that since Pasteur's announcement in 1880, workers since that time have had irregular results with various vaccines and bacterians, and that immunization has never been accepted as a dependable control measure for fowl cholera. Louis Pasteur is often credited with proving germ theory through his rabies research and vaccine development. However, his methods defied logic and were criticized by his peers in the scientific community, including German bacteriologist Robert Koch. Pasteur began his experiments by obtaining the saliva from a child who was reported to have died from rabies and injecting it into 2 rabbits. After these 2 rabbits died, Pasteur was convinced that he had demonstrated transmission of rabies and began work on a vaccine for the saliva microbe. 2 major problems with this experimentation presented themselves immediately. The saliva was not introduced into the animals thought to carry rabies, that is, dogs, and the sample was not taken directly from salivary gland organs which were hypothesized to carry the disease. In addition, saliva was known to house many pathogenic bacteria, and the sample could not be confirmed to be a pure representation of rabies. No mention was made regarding how and where the rabbits were injected prior to their deaths. Finally, subsequent attempts to replicate this effect with saliva samples were inconsistent and did not produce the immediate results reported from Pasteur's initial studies. A new method of replicating the disease was devised that involved injecting the brain and nervous tissues from diseased animals into the brains of healthy animals. This procedure involves strapping test subjects to a table, sedating them with chloroform, cutting a piece of the skull open, and injecting a mixture of brain matter and solvents into the animal's brain. This line of experimentation took an even darker turn during the development of a rabies vaccine. The first step of development involved inducing madness in a dog through injecting a mixture of brain matter and solvents into the dog's brain. Once the dog succumbed to mutilation and starvation, its blood would be withdrawn and injected into the brains of monkeys in the same manner. The blood of the dead monkey would then be inserted into the brain of a rabbit. The brain of the dead rabbit would then be ground, dissolved in solvent, and injected into the next rabbit. This method of injecting many subsequent rabbits was known as pass-through and repeated up to 100 times. At the conclusion of this process, incisions were made into a live rabbit and a combination of bacteria and chemicals applied to the wound to induce an infection. The pus, or lymph, that formed by the wound was extracted, mixed with formaldehyde, and used as a vaccine. This mixture was first given to a 9-year-old boy named Joseph Meister on July 6, 1885, after claims of testing it on 50 dogs without a single failure. Pasteur's journal would tell a different story, however. The dosage strategy for Meister was exactly opposite of that used for dogs, and no experimental evidence could be found to corroborate the extent of safety and efficacy testing in animals that had been performed prior to human trials. Critics of the day brought attention to the failure of Pasteur's wonder drug in providing protection and accused it of being the source of many rabies deaths. Another accomplishment ascribed to Pasteur was his creation of a vaccine against anthrax. Pasteur claimed to have been the first to establish causality between anthrax bacterium and disease during his study of the diseases of silkworms. His contemporary and chief rival, Robert Koch, called this work into question because of Pasteur's use of impure substances in producing the results and the use of unsuitable test animals. He furthermore questioned Pasteur's unwillingness to share his experimental methods, a common practice in scientific publications, and tendency to overlook results that went against his hypotheses. Koch concluded that his biases got the better of him, and he reported wonderful things about the diseases found in test animals and about the remains in their corpses. After all, Pasteur is not a physician, and one cannot expect him to make sound judgments about pathological processes and the symptoms of diseases. He further stated that anyone who expects to be accepted in the scientific community must publish his methods, so that everyone is able to test the accuracy of his claims. Pasteur has not met this obligation. Pasteur's publications on the preparation of the 2 inoculation materials are so imperfect that it is impossible to repeat his experiments and to test his results. With respect to Pasteur's anthrax vaccine development, Koch summarized the results in saying, "All what we heard was some completely useless data." Pasteur attempted to show effectiveness of this new vaccine by reporting how many sheep and cattle did not die after being inoculated with the solution. Regarding this matter of reporting outcomes, Koch stated that Pasteur says nothing about our main concern, namely whether the inoculations fulfilled their purpose and made the animals immune. Certainly nothing would do more to ensure acceptance of anthrax inoculations than knowing that thousands of animals have been protected against anthrax. As yet, Pasteur has not been able to show this. On the contrary, complaints about failures of the inoculation are accumulating and its weaknesses are becoming ever more obvious. Koch concluded his critique by saying, "On the other hand, it is very surprising that Pasteur, who conscientiously included the animals inoculated with weak vaccine in order to arrive at the largest number of inoculations with the smallest number of losses, completely ignored the many failures that were known to him." History, as they say, is written by the victors. It is also dogmatically repeated as gospel truth in mainstream outlets. According to ChatGPT, one of Pasteur's key accomplishments in establishing the field of immunology was the demonstration that publicly tested anthrax vaccine on livestock, successfully immunizing them against the disease, and that it was the first major success in using controlled microbial infection to prevent disease. Overlooked in this characterization are the obscuring of methods, confirmational bias, and questionable means of getting results. Pasteur is perhaps most famous for the process of pasteurization, which was developed while studying fermentation in wine and beer at the request of French vintners who sought methods to avoid wine spoilage. The most common application of pasteurization is in milk, which is nearly impossible to find available for sale in its raw form. Studies by Carl F. Meyer and E.B. Shaw from 1918 to 1920 were pivotal in convincing the public at large that pasteurization of milk was necessary for safe consumption. The paper entitled "The Pathogenicity of B. abortus and B. melitensis for monkeys" detailed methods for obtaining the suspected bacterial pathogen, Brucella in this case, and proving its transmission, that would make the average person scratch their heads when hearing them described. First, Brucella was obtained from the urine and testes of guinea pigs and then cultured. The cultured bacteria were then injected into guinea pigs and followed by the extraction of blood from their lymph nodes. An alternative method of obtaining the bacteria was through the extraction from aborted hog fetus livers and injection into guinea pig testes, following the rest of the procedure previously described. Now that researchers had a solution they believed to contain the Brucella bacteria, they moved on to testing it in monkeys. They began by feeding monkeys with carrots or milk tainted with the guinea pig-derived culture. To their surprise, the monkeys were resilient, and many survived the experiments in accompanying starvation and other physical abuse. Researchers then increased the amount of cultured material added to a variety of food items, including apples and bread. Frustrated by the numbers of monkeys who persisted, researchers then euthanized the surviving monkeys and claimed that lesions on their internal organs demonstrated infection by the bacteria. Alternative experiments injected the guinea pig-derived culture into the jugulars or veins of monkey test subjects. The monkeys would experience frequent anal probing for temperature checks and blood withdrawals before eventually succumbing to their conditions or being euthanized. In many cases, monkeys were reported as being emaciated weeks after arriving from their native lands. Given the researchers' failure to show a direct linkage between consuming tainted food and infection, they then tried injecting the feces of monkey subjects into guinea pigs. Unfortunately for the researchers, the guinea pigs injected with monkey feces did not have the expected lesions on their organs. Their final attempt at proving causality was to once again increase the amount of cultured material given to monkey test subjects and to concurrently give them laxatives. It was thought that test subjects showing signs of fever or diarrhea indicated successful transmission of the suspected pathogen. These very unusual studies were used as justification for mandating pasteurization of milk sold to the public starting in 1924. Interestingly, newspaper articles from the early 1900s proved that plans were already underway to build the necessary infrastructure for milk pasteurization. I hope you now have a clear understanding of the science that made Louis Pasteur famous and that has led to many of the practices still performed to this day resulting from the development of germ theory. More importantly, you should now be armed to reevaluate the foundations and claims of germ theory through the examination of past experiments which have long been considered settled science. Join me in part 2, where we'll explore commonly held perceptions about the Spanish flu and polio. I'd like to take a moment to acknowledge the investigators, journalists, and content creators whose hard work I've made every effort to summarize and represent accurately. I could not have presented this material without the countless hours they've all dedicated to exposing the truth about what really makes us ill. If you enjoyed this video or other content on this channel, please like, subscribe, and share with others. Consider making a donation to help me do this full time. I look forward to seeing you in the next episode.